And it's just like, what are you doing? Like, actually, what are you doing?
Good morning, ladies and gentlemen. How are we doing today? Wonderful, 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 excellent, awesome, amazing, incredible, ladies and gentlemen. All right. Get your computers, get logged in, ladies and gentlemen. I'm going to be sharing a Pear Deck with you. But today's Pear Deck, ladies and gentlemen, is going to be a self-paced one. That means you go at it as fast as you can. In the Pear Deck, ladies and gentlemen, you are going to be calculating formula masses. So that is why I'm giving you some scratch paper right now. Share with Phoebe.
No, Phoebe stinks.
That's funny, she said the same thing about you yesterday.
I've never said anything bad about her.
I never said anything bad about Phoebe.
You never said anything good about her either.
What do you mean I praised her?
Right, okay, good over. Our summer school.
Sheds a share. I know it's not in your nature, but try it anyway. Can you turn the light off?
Wait,
Hit the button twice on the side. There. Otherwise, we just waste battery. All right, ladies and gentlemen. All right, there is the Pear Deck for you, ladies and gentlemen. Okay, so again, the Pear Deck has a number of questions. Calculate the formula mass of diphosphorus pentachloride. Okay, so take a minute, write the formula down on your paper, take out your periodic table, calculate the formula mass for them. Now, you do not have to do them all. Okay? Do the ones you think you need to do. If you don't know how to do any of them, well, you're in trouble anyway. So I guess we're going to have to figure that out as we go. So we're going to give you about 7 minutes here, ladies and gentlemen, to get them done. Timer is running. Well, as soon as I actually set it. There you go. 7 minutes. Clock is running, ladies and gentlemen. All right, ladies and gentlemen, let's take a look at this, go over this, see if you have any questions on anything, and if you do, let's see if we can answer them for you. So, first thing you need to be able to do to write a formula mass is you need to be able to write a formula. So, diphosphorus pentachloride, Angel, what do you got?
P2CL5.
Perfect, P2Cl5, okay? P2Cl5, ladies and gentlemen. So when you do that, ladies and gentlemen, you should come up with a formula mass of around 239.19 grams per mole. Anyone have any questions? Am I close? Anyone do it? Okay, good. So that number is okay?
Yes.
Okay. Please remember, if you're off by a little bit, if you've got 239.5, 238.9, somewhere around there, we're okay to be a little bit different. I think for these, I used the masses that came off of your periodic table, though. Okay? Questions?
No.
Now, here's the other thing, and this is something that people started asking me about yesterday when we were doing the lab, which we'll get to in a few minutes, ladies and gentlemen. I will never grade sig figs in the middle of a problem. Okay? So, for example, you're going to have to calculate a formula mass to convert a number from moles into grams or grams into moles. The only time I grade sig figs is at your final answer. That is the only place where you need to worry about sig figs. Okay? So if you got this number in your calculator and it's got a bunch of digits and you're like, how many of them do I write down? Don't even worry about it. Okay? Don't even worry about it. The only place I grade sig figs is in the final answer of a problem. Okay? So if there's an intermediate step, if it's a number that you're using a molar mass for or a formula mass, I'm not going to look at that and go, oh, you put 239.2, you lose a point for a sig figs. No, never happened. Never happened. Okay? All right. Hydrophosphoric acid. Formula for hydrophosphoric acid, Stephen.
H3.
Pick it up. Thank you.
H3PAQ.
H3PAQ, absolutely correct. Formula mass 34 grams per mole. Please remember, hydro means binary acid. Binary means only two different elements in the acid. The first one has to be hydrogen. Okay? Phosphoric comes from phosphorus. It's a -3 charge. That's how we get the formula, ladies and gentlemen. Are we good with that formula mass? Yes? Okay, we'll move on then. Zinc hydroxide. What would be the formula for zinc hydroxide? Jasmine, did you get that far? Okay, what's zinc, Jasmine? What's its charge? Okay, what's hydroxide? Flip over and look at the back of your sheet. Okay, so how many OHs would I need to balance off that zinc? Which is a +2. What's that? Well, your formula is going to be Zn, OH in parentheses 2 to balance off the zinc. Okay? Now, when we add the zinc, which is 65.38, 65.39, somewhere in there, plus 2 oxygens at 16 each, that's 32, plus 2 hydrogens, that's 2.02. We come up with 99.4 grams per mole. Questions, ladies and gentlemen? Okay, last one, iron 3 sulfite. Iron 3 sulfite. Jaden, what do we get for that? Okay, Fe2, SO3 in parentheses with the 3 outside. Iron has a +3 charge. Sulfite has a -2 charge. The -2 comes down here. The +3 goes down here, ladies and gentlemen. Okay? Formula mass 351.88 if I did my math correctly. 2 irons. Iron has, 55.845 something. Is that 55? Yeah. Sulfur is 32.06 times 3. And 9 oxygens at 16. Okay? 144. Add those all together, we come up with the 351.88 grams per mole. Questions, ladies and gentlemen? Okay. Now, one of the things I want you to understand, what this is telling us right here, ladies and gentlemen. Okay? This is, this is 351.88 grams per mole. What that means is that when we have 351.88 grams of Fe2SO3, that is equal to 1 mole of Fe2SO3. Okay? That means I can make a conversion factor out of this. Because these two are equal to each other, I could do this. I could use it that way. Or I could use it this way. Either way is okay to use. Why? Because they are equal to each other. And if I put a fraction that has the top equal to the bottom, I am just multiplying by 1. So I don't care which one of these I put on top and which one of these I put on the bottom. They are equal to each other. When I have 351.88 grams of iron sulfite in a container, I have 1 mole of it. Okay? I have 1 mole of it. I can use it this way. I can use it this way. Today we're going to figure out which way we use it. Today we're going to figure out how we use that. Questions? Okay. Now, one of the things I want to point out to you. Yesterday we did the mass versus mole lab, ladies and gentlemen. Okay? It is here in Google Classroom. Let's do this. Don't. Get out of there. Get out of there. Okay. So in Google Classroom, ladies and gentlemen, here is the mass versus mole lab. Okay? Now, 9 of you have turned it in. 15 of you need to finish it and get it turned in today. Yesterday, we went over it. We talked about it. Today, I'll ask this. Do you have any questions on the lab that we did yesterday? So you should be able to get the 5 or 6 questions answered in that lab. You should turn it in before the end of the day today, ladies and gentlemen. I will grade it and I will put it in the grade book for you. Questions? One thing I want to point out, and I pointed this out last trimester and I will point it out again. When we look at your assignments, ladies and gentlemen, okay? Caden, I'm going to pick yours just because you're here. Okay? Here's Caden's lab. Okay? He's got his stuff done in here, ladies and gentlemen, and that is fine. Eventually, I think he already actually, well, he has to turn it in yet. It's still, nope. Yeah, it's still got to be turned in. So at some point, you got to turn it in. Okay? Ben, I think you were absent. Were you absent yesterday, Ben, or no? No. Was there someone who was absent yesterday? I thought there was. Anyway, ladies and gentlemen, if you are ever absent, I will go into the lab for you, and I will literally take out this lab, and I will replace it with an alternate assignment. And here's what the alternate assignment looks like, ladies and gentlemen. For the alternate assignment, ladies and gentlemen, I will put in pictures so you could still make observations. You weren't here. You couldn't do the lab. I don't want you having to try to come in after school. I don't want to have you try to come in before school, because here's the honest truth. I teach 3 different lab courses this trimester. I am setting up labs and taking them down all the time. So I can't leave them sitting out there for you. Okay? Some of our labs may take 2 days. If you miss 1 day, I'll let you make it up by getting your partner to help you get caught up. But if it's a lab like this and you miss it, okay, here's the pictures. You make observations on it. Okay? I will take and I will put this right into your assignment. So when you go into the assignment, you will see this. I put in the masses of the large bags for you. I put in the masses of the 50 pieces sample. You just need to finish it. Okay? You just need to finish it. Now, if you're sitting there and go, well, how do I know what to do? How do I know how to do all the math? That you may have to come and see me for. But that we can discuss real quickly before class. We can discuss it after class. We can discuss it while you're doing work time. The point is you can finish the lab. And you don't have to make special arrangements with me to come in before or after school. And when you go in the lab, your lab is going to look different than the person who was here that day, because I have to give you more information than I did them because you weren't here to make the observations and things. But everything you need should be in here for you. Okay? So no excuse why you cannot get the lab done and get it turned in. Again, does anyone have any questions on this lab? Because there are still 15 of you who haven't turned it in. Okay. Please get it turned in by the end of the day today. Okay? Or as we say, before tomorrow. Okay. Excellent, ladies and gentlemen. Then here we go. Okay? Open up your EISN and get to slide number 10, ladies and gentlemen. Get to slide number 10, okay? We are going to talk about converting with the mole today, ladies and gentlemen. I'm going to go over a few examples with you. Then we'll go to our worksheets and we will start doing some problems out of our worksheets, okay? That is the way that this is going to work, okay? So, a problem would be something like this. Calculate the mass of 6.89 moles of antimony. Okay? 6.89 moles of antimony. So in this problem, we are going from moles to mass. Okay? The only way we can get from moles to mass is to use what is called formula mass. Okay? So the... Okay. Now, as I was saying, ladies and gentlemen, we need a formula mass. Now, formula mass for antimony is easy. Why? It's an element. An element, all you've got to do is look at the mass that is given to you on the periodic table. So the molar mass for antimony, the formula mass, if you will, I don't care which term you use. I don't care which term you use. You want to use molar mass, you want to use formula mass, they can be used absolutely interchangeably, ladies and gentlemen. The molar mass for antimony is 1 mole of antimony is 121.76 grams. 121.76 grams. We are going to make a conversion factor out of this to get out of our unit of moles and into our unit of mass. Now, what unit is there for mass? What unit should it be? Grams. And that's what we have here, grams and moles. So we begin, ladies and gentlemen, by writing down what we're given, 6.89 moles of antimony. We then take this and make this into a conversion factor. That means part of it goes on the top of a fraction, part of it goes on the bottom. Which part of this has to go on the bottom of this fraction and why? Pierce. Why? Because we want it to cancel out. We want to get rid of this unit of moles, so we want to cancel it out. So we're making a unit cancellation, a conversion factor. We're making a fraction out of this to get rid of moles. So the only way to do that is to put the mass on the top and the moles on the bottom. Because now mole and mole will cancel out, ladies and gentlemen. Mole and mole will cancel each other out. There's only two ways to go here. From moles into mass or from mass into moles. We are going from moles into mass, so we put the mass on top, mole on the bottom. Formula mass calculated just like we showed you yesterday. For an element, you grab it right off the periodic table. Now you are going to do your math, ladies and gentlemen. You are going to take 6.89 times 121.76. You're going to get an answer. Now, again, in my calculator, it may give you a number with a bunch of decimals. Sig figs. How many sig figs in this number? That's all you need to look at. I don't care how many sig figs are here. I don't care how many sig figs are here. These are conversion factors. They do not limit sig figs. 3 sig figs up here means your final answer needs to be in 3 sig figs, ladies and gentlemen. And again, I've told you this before, and I will tell you this again. 99% of the time, how many sig figs should your answer be in? 3. 3. Okay? 3. So if you're really confused, put it in 3 sig figs and be done. But it shouldn't be that hard because that number right there determines how many sig figs you use. Questions? Easy enough? Okay, I believe that for a second from you. A sample of potassium chloride has a mass of 223 grams. How many moles of potassium chloride are present? So now we're starting out in mass, 223 grams, and we are trying to go to moles. If you're going from mass to moles, we need a formula mass, ladies and gentlemen. You have to have a formula mass. So the formula mass for potassium chloride, the formula is KCl. Potassium's a +1, chlorine's a -1, KCl. So for 1 mole of KCl, it is 74.55 grams. Why? Potassium, 39.0983. Again, it's a little different on your periodic table, but I think it's 39.09 or 39.10.
For potassium?
Yes.
39.10.
39.10. Okay, 39.10. Chlorine, 35.45 on your periodic table. Add them together. You get 74.15. Questions? Start with what you're given, 223 grams. We're now going to take this and we're going to make this into a conversion factor. But now, which part has to be on the top? Which part has to be on the bottom, ladies and gentlemen, and why?
Grams on the bottom.
Why?
To cancel it out.
To cancel out. Now, if it bothers you that there is nothing under this, that this is just a number that we are beginning with, put it over 1. Would mean the same thing, okay? But this is like being on the top of a fraction. So we again are going to set up a fraction. 1 mole on the top, grams on the bottom. Okay? 1 mole on the top, grams on the bottom. How many sig figs in our question? How many sig figs need to be in your answer? 3. So out of my calculator, I got 2.99128. I stopped there. Why? Because I know I only need 3 sig figs. That means, final answer, 2.99 moles of potassium chloride. Now, on your quiz on Friday, you will get 1 point for giving me the correct formula. This conversion is actually worth 2 points, ladies and gentlemen. 1 for setting it up correctly, mole on top, grams on the bottom, or grams on top, moles on the bottom. And 1 for correctly doing your formula mass. So this is 2 points. Your answer is worth 2 points. The 2 points in your answer, 1, the correct number. The last point is you have to have the correct unit, and you have to have the correct sig figs. You don't have a unit, you don't have the sig figs, you lose 1 point. So this is a 5-point problem, ladies and gentlemen. If you do not have the correct sig figs, you lose 1 out of 5 points. Questions?
No.
Any? Okay. So now, a sample of gas occupies 18.6 liters at STP. Now, I will tell you this. I am going to try to confuse you. No, I'm not. Because I'm telling you right now, if I give you a pressure, if I give you a temperature, it has to be STP that I am giving you. We cannot work these problems unless they're at something called STP, standard temperature and pressure. Okay? You cannot do it. All right? A sample of nitrogen gas occupies 18.6 liters at STP. How many moles of nitrogen gas are present? Okay? How many moles of nitrogen gas are present? For this problem, we are using this fact. 1 mole of any gas is equal to 22.4 liters. This never changes. Never. At STP, that is what the conversion always is. 1 mole equals 22.4 liters. That number doesn't change. In this entire unit, if you are going from volume to moles or moles to volume, you are using 22.4. The entire unit. That is what you are using. Okay? Questions? So what are we starting out with? What's our number to begin with? 18.6 what? Liters. Okay? But, why is nitrogen squared? Oh, that's not squared
See,
down there.
you said it too. Subscript.
No, I was making fun of you for saying it.
Well, you made me feel better about it.
Did I?
You did.
Did I? I've already given you this answer, by the way, ladies and gentlemen.
Okay. Well,
Anybody remember?
Can't be alone.
Why?
You told me that.
What? I told you so. I did. I did. I warned you, ladies and gentlemen, that there were 7 diatomic molecules. Hey, guess what? If you write the formula of nitrogen as just N, guess what's going to be wrong about it? Right, there's no 2. But it really won't affect this, because 22.4 never changes. But what if we were going to grams? And you write just N. What's your formula mass going to be? 14.01. Half of what it should be, 28.02. Got to get the formula right. You remember those periodic tables that you had, ladies and gentlemen? I would take those out right now. And if you don't got one, I would go grab one. Okay? I would go grab one, ladies and gentlemen. We're going to put a little addition onto here for you, ladies and gentlemen. Little addition onto it for you. Okay? So here we go, ladies and gentlemen. Da, 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 da. There we go. All right, this seems like a good place right down here at the bottom, ladies and gentlemen. 7 diatomics. H2, N2, O2, F2, Cl2, Br2, I2. There they are, ladies and gentlemen. That's all of them. Those are your 7 diatomics. So when we start talking about nitrogen gas, hydrogen gas, oxygen gas, that is the way they have to be written. But please remember, if they are in a compound with another element, they do not have to be diatomic anymore. Now they're becoming stable by being in a compound. So it is possible to have only 1 chlorine in a compound that is a gas. But it is not possible to have chlorine just Cl when it is alone. Are there any questions on that? Olivia, can you see that, or do you want me to move that up some? Okay. Questions? I don't know. Okay. Oh, there's a good color. There's a good color. Okay. Now, again, you do not have to put my notes on your periodic table. If you want to wing it, please feel free to, ladies and gentlemen. Okay. I'm going to put one other note in here, ladies and gentlemen, and I'm going to do it right under where it says periodic table of the elements. Okay. Did everybody get those diatomics? I'm sorry. Was anybody still using those? Okay. Here's what I'm going to do. I am going to put mole right there. I'm going to put mole right there. And then over here, I'm going to put an arrow, and I'm going to put volume. In other words, we can go from volume to mole. Okay? We can go from volume to mole. Okay? It has to be at STP. You have nothing to worry about in this unit. Everything that I give you will be at STP. What is the magic number to get from volume to moles? So 22.4 liters equals 1 mole. That is always what we will use. Always. Okay? No ifs, no ands, no buts. That is how you will get from moles to liters or liters to moles. Okay? Remind me, I gotta give you the wrinkle in a minute. Don't let me forget. Okay? All right? It's not a hard wrinkle, but remind me. Okay? All right. The other thing we can do is we can go from moles to particles. Okay? Now, particles could be atoms, could be molecules, or could be what? What was the third one? And it was the technicality, because we cannot call all compounds molecules. No. That has to do with mass, though. You are right there. The other one was called a formula unit. A formula unit. Okay? So those are the particles. If it's an ionic compound, we would technically call it a formula unit. Now, here's the honest to goodness truth. I am not going to mark a conversion wrong on a test, on a quiz, because you accidentally used the word molecule instead of formula unit. I'm not going to mark that wrong. Okay? But here's the one thing I will warn you. If you're going to abbreviate molecule, do not abbreviate it MOL or MOLE. Why? That's mole. You're going to confuse the two. Okay? If you're going to abbreviate this, you got to at least get to the C. MOLEC, something like that. Okay? So please don't confuse those. What is the magic number for particles to go to moles?
6.02 times 10 to the 23rd.
So I'm going to put it above. No, I'll put it down below. 6.02 times 10 to the 23rd particles equals 1 mole.
$6.
6.02. Sorry, this isn't the greatest 6 I've ever written. How's that? A little better? Probably not. Can't erase it. Sorry. I hope you get it correct. Okay? So whenever we go from moles to particles or particles to moles, we're using the ugliest 6.02 you could ever possibly imagine times 10 to the 23rd. Questions? So there's one thing left. What can we go to still?
Mass.
Mass. We've been doing these. You can go from moles to mass. Okay? To go from moles to mass, though, what do we need? Well, okay, I understand that. But let's not write a whole book here. What do we need to go from moles to mass? The what? We need the formula mass. The formula mass equals 1 mole. The formula mass equals 1 mole. Now, again, I'm not going to put in here how to calculate formula mass. Hopefully you know that. If not, you've got plenty of periodic table that you could write it down on here. You don't like this periodic table, get a new one. Okay? Questions? All right. We ready to go? No, you were supposed to remind me of the wrinkle.
I wrote it down too.
It does a lot of good if you wrote it down and you don't remind me. Here's the wrinkle.
I didn't know what time you wanted.
The wrinkle is volume. And here's what the wrinkle is. A lot of times I don't want the volume in liters. I want it in milliliters. So please remember, 1,000 milliliters equals 1 liter. And you may have to use that simple conversion, ladies and gentlemen, to get from liters into milliliters, or to get from milliliters of a gas into liters, because that's the only way we can use this. Okay? So if you're given milliliters of a gas, you cannot directly convert that with this. You have to take milliliters and get to liters. Then you have to use this to get 2 moles. Questions? So we can go from volume to mole. We can go from mass to mole. We've been doing those. We're going to finish this in just a second. And you can go from particles to moles. All in one step, basically. Questions? Pierce, what do you got? You're not allowed to stretch in here. Stop it. Right away. Right away. Got to be a rule breaker. Okay. Shenza's over there going, we're not allowed to stretch in here? What? Yeah, whatever. That I'm done with. All right, let's get back to this. Okay, so what part of our fraction has to go on the top? What part has to go on the bottom? Yes, that one. Good. Come on, help me out. Mole on the top, liters on the bottom, ladies and gentlemen. That way liters and liters cancel out. Notice we're using 22.4 because that's the only thing we'll ever use in this unit for liters. Okay? 22.4. Maybe if it's really little in your box, hit Control and the comma key. Maybe it's typing in a subscript mode. Highlight it and try that. It might be because I might have, left it in the subscript mode because of that. All right. Are we multiplying or dividing by 22.4 here? Why? Because it's on the bottom. Good. Not hard math, right? Not hard math, right? Good. So out of our calculator, we get 0.830357414. We got way too many numbers there. How many do we need? 3. Why it's a good idea to know how many sig figs before you're done punching it into your calculator. Once I know I only need 3, I don't have to look at all this gobbledygook. I can stop after the 3rd sig fig. By the way, is this 0 a significant fig? No, because it's at the beginning. Here's the 1st sig fig, 2nd, 3rd. Questions, ladies and gentlemen. By the way, this is only a 4-point problem. 1 for the formula. 1 for setting this up properly. I'm not giving you credit for calculating 22.4. It's the only number you use. And then 2 for your answer. Questions? Now, again, you don't like my system here? Okay, come up with a better one, but I better be able to understand why you either multiplied or divided something by some number. Okay? Because if all you do is magically give me an answer, you're losing the points for the steps in the middle. Now, you may be like, well, that's okay. It's only one step, 1 point. Wait, it gets better, ladies and gentlemen. Questions? We're good? Okay, let's take a look at our next one then, ladies and gentlemen. A sample of carbon dioxide gas contains what? Great English. A sample of carbon dioxide gas contains 3.79 moles at STP. How many liters of space would the gas occupy? Okay, going from moles to volume. Good. So 1 mole of gas equals 22.4 liters. 1 mole of carbon dioxide gas equals 22.4 moles of carbon dioxide gas. In this problem, you really don't need to write the formula. You're not using formula math, but I am going to give you a point on the test for writing the correct formula. Okay? Just to practice it, just to get better at it. So we're beginning with 3.79 moles. What goes on top? What goes on the bottom? Okay, what goes on top? 22.4 liters on top, 1 mole of CO2 on the bottom. Are we multiplying by 22.4, dividing? Multiplying. 84.896 liters. 3 sig figs again, because every problem we've done so far today has had 3 sig figs. Most problems will have 3 sig figs. 3.79 is 3 sig figs. 84.9, ladies and gentlemen. By the way, don't round it incorrectly. This one, there should be no discrepancy on between you and your neighbor. Why? You're using 22.4. You're not using 22. You're not using 22.39. You're using 22.4. Should come up with the same answer. Questions? Okay. Well, there's only one thing left, ladies and gentlemen. From moles to particles. How many atoms are in a sample of 5.565 moles of gold? Now, first of all, what kind of number are we going to get here? Okay, but what kind of number is it going to be? Okay, but what kind of number is it going to be? It's going to be an incredibly large number. Something with a times 10 to the 20s. Okay? We're expecting a really large number here. Why? Because particles are really small. Okay? So, where did I lose my thing here? Come on, come on. All right. So 1 mole of sample, any sample, is equal to 6.02 times 10 to the 23rd particles. What particles are making up this sample? Atoms of gold. Why? Gold is an element. Elements are made up of atoms. So 1 mole of gold atoms equals 6.02 times 10 to the 23rd atoms of gold. Okay? So again, we take our number. Final answer, how many sig figs? 3. That means that our number in front of the times 10 to the is going to be something, point, something, something. The number in front of the times 10 to the shows you your sig figs. Okay? So, what goes on top? What goes on the bottom here? Top or bottom? 6.02 times 10 to the 23rd atoms on top. What goes on the bottom?
1 mole.
1 mole. 1 mole. Okay. Now, your calculators, ladies and gentlemen, or my calculators, or whoever calculator you're using. To do this correct, and the easiest way, you need to find the scientific notation key on your calculator. If you are using one of mine, and it is the TI-30X IIS, right above the 7 key is x to the minus 1. Above that, in yellow, it says EE. That means that it is a second function. So if you want to input 6.02 times 10 to the 23rd, ladies and gentlemen, you need to put in 6.02 and then hit the second and that E button. It will put an E in your display. And now you type in the power. Now, if you want to do this differently, if you want to use the caret key or something like that, you figure out how to do it because you're making it more difficult for yourself. This tells the calculator that this whole thing is one number. The whole thing is one number. If you cannot find your EE button, I can help you. Did you find it? Yeah, EX, the times 10, that button. And that's okay. Your calculator puts times 10 to the instead of the E. Means the same thing. Okay? An older calculator, Texas Instruments, might put times 10 and then like 2 little numbers after it, 0, 0, where you can put in your exponent. Yes. So yeah, just hit the E button. You don't have to hit the second. Do you know where it is on there, David? Yeah, so it's again a second function. So you gotta hit the second. Are you guys good?
Can we just
Okay, I don't. Phoebe's question is a valid question. Can I just use the caret key?
Yeah.
Okay, here's the problem. If we are dividing by it, you're going to have to put everything in parentheses then. Because what will happen is it will take your number, divide by 6.02, and then take it times 10 to the 23rd power. And you will get an incredibly large number instead of an incredibly small. When you use the EE button, it says to the calculator that is all one number. So if it's on the top or if it's on the bottom, it's going to treat that all as one number. If you use the caret key, it says here's part of it, here's a number, and then here's another action to do. So if you don't put that all in parentheses, it's not going to divide by the whole thing. So there it is, right about there. So you hit second, that button, and it'll put the E, and then you type the power.
Okay.
After the E, you type the power. Some older calculators or some other ones that may put times 10 to them. Then you type in your power. Alright?
You get that?
Do not between the 6.02. Okay, you can do it that way, but I'm telling you, when you divide by that, you're gonna have to put everything in parentheses. Your choice. We good? Scientific notation. The EE button above the X to the 1. So you hit second, and you hit that, and you're in scientific notation. Okay? Nope, the one over that one. Second, that one. There you go. Good? Good? Yes. Good? Okay. And that's fine. That's fine. That's what it's supposed to be. So right now in your calculator, listen, type in 6.02, second EE23 and hit enter. And it should display at the bottom 6.02 times 10 to the 23rd. Should show it to you. That means you have entered it in correctly. Okay, yours is right there. Oh, there. Okay, so hit 6.02. Hit that EE button. You don't need the second. Now up there, you're going to type in your power. Okay? Up there, you're going to type in your power. So on this calculator, when you get a number, it's going to put the power up there, and it's going to put the base number there. Good? Good? Good, gentlemen? Okay, now type in 23. Is it enter? Okay, so that's the way you put that number in, ladies and gentlemen. Okay? Now again, you can do it your way. I have absolutely no problem with that. But if it leads you to making an error later on, hopefully you'll understand what you got to do. Are you guys good? Good? No? Okay. So yours is this times 10. So put
What
in
else is there to
6.02.
do?
Hit that button, and now type in your power, 23. Okay? And that's how you will enter that number. Okay, it equals 1. So then it puts it down there for you that way too. Okay?
Oh.
So hit 6.02, hit the second, and then hit the E button, and now hit 23. Now hit equals. All right, now here we go, ladies and gentlemen. So listen, on your calculator right now, type in, clear it, do whatever you got to do, 0.565 times 6.02. The EE button, either second EE times 10 to the X, or just the EE button, and then 23. Now, hit enter, and if you did it correct, you should get this value, ladies and gentlemen, 3.4013 times 10 to the 23rd. That is the number that you should have gotten out of your calculator. Shenza, even if you did it with the caret key and the times 10, okay? Now, listen. If you got times 10 to the 24th, you probably did 6.02 times 10 and then hit the EE button. Don't do that. The EE button takes the place of the times 10. Okay? If you do 6.02 times 10 and then hit the EE button, it is multiplying this by 10 and then raising it to the power of 23. You've made your number 10 times bigger. Anyone need help? Anyone not get this as an answer?
You got 24.
Okay. So, again, do not do times 10 and the EE button. The EE button takes the place of the times 10. So you type in 6.02, second EE, and now you will get the correct answer. The EE button takes the place of times 10. It says, take it times 10 raised to this power. Don't do both. Questions?
Oh my god. You had to write that down.
Now, here's what I hope, ladies and gentlemen. How do we recognize that this is a really big number? 10 to the 23rd. How would we recognize if this was a really small number? What would be negative? The power would be negative. The power would be negative, not the number. The power would be. So again, if you're inputting it a different way and all of a sudden we're expecting a big number and you get a power of negative 23, you did something wrong. Okay? You did something wrong. So please be careful. Questions?
Yeah.
Yes? What's the question?
No.
No. Okay, good. 1.36 times 10 to the 23rd molecules of water are in the beaker. How many molecules of water are in the beaker? So again, 1 mole of sample equals 6.02 times 10 to the 23rd particles. What are our particles here? Molecules. What is a molecule made up of? What is a molecule, this molecule made up of?
Water.
But what is, I'm agreeing, water?
H2O.
H2O. So now, first of all, the particle is water, H2O, a molecule of it. But that molecule is still made up of other things. This is just asking you how many moles of water there are in this many molecules. Okay? So, again, 1 mole of water is equal to 6.02 times 10 to the 23rd. We are beginning with 1.36 times 10 to the 23rd molecules of water. What does our fraction look like? What does our conversion factor look like? I say fraction, I say conversion factor, they mean the same thing. What goes on top, what goes on bottom? 1 mole on top. 6.02 times 10 to the 23rd molecules on the bottom. Okay? Now, think about this. This is to the 23rd and this is to the 23rd. What does that mean our numbers should be near? Please don't say 46th. What? Not necessarily smaller than 0, but I'm expecting a number around 1. Smaller than 1, a little bigger than 1. So I'm not expecting something with the power of 23, something with the power of 20. Okay? In reality, this part and this part cancel out. So, in your calculator, now here's where, if you don't put it in the right way on the bottom, you're going to end up with problems. 1.36 EE 23 divided by. Now again, if you want to use the caret key, if you want to use something else, you're going to have to put this in parentheses because we're dividing by 6.02. If you use the scientific notation button, you don't have to do anything other than type in the number and hit equals. What you should have gotten, ladies and gentlemen, is this. This is the number that should have come out of your calculator when you hit equals. If it didn't, call me over and I will give you some help. Okay? Call me over and I will give you some help, but that's the number that you should have gotten.
Okay, but you don't do the times 10. Is that right? The EE takes the place of the times 10. So after you get to our 1.36, you do the EE button and now put in the power. 23. Now, divided by, because that's what we're doing next. 6.02. EE button. 23 equals. Better? Oh, you missed the EE button. See up here? When you hit the EE button, it should put an E there. Now put in 23. That tells you you're inside the notation. Now hit enter. Okay? Questions?
Yes, no, maybe so. Let's save that for a minute. Okay, take out your packets, ladies and gentlemen. All right, get to the molar conversion. I'm sorry I don't have the pages numbers, but it says Chemistry Unit 5 Worksheet Mole Conversions at the top. All right. Oh, go back. All right. So here we go, ladies and gentlemen. Number 1, formula for sodium hydroxide. What is the formula for sodium hydroxide? Somebody, please. Don't everybody holler it out all at once, please. I can't hear you when you do that. NaOH. Okay, so we have 1 Na, 1 oxygen, 1 hydrogen. Sodium, 23.98. 9 what?
99.
23.99. Oxygen 16.0. 1.01. So what is it? 40.0 grams equals 1 mole. Have to find the formula mass. Joshua. 22. Sorry. I think we have the right we have the right number. I just wrote it down wrong. Thank you. Okay, we'll blame Josie for that.
Okay.
She told me 23.
I didn't say.
Okay.
I was mad.
So we begin with what we're given. 0.375 moles. We are now going to take this here. 40 grams equals 1 mole, and we are going to make it into our conversion factor. What goes where? 1 mole goes on the bottom. So 40.0 grams goes on top. Now, here's what I will tell you, ladies and gentlemen. People always say, Mr. Brand, do I have to write units? Yeah. It's how we set up unit cancellation is based on units. If you write 0.375, you're not going to know which one of these goes on top, which one goes on the bottom. Okay? So you have to let the units help set up the problem for you. Mole and mole will cancel. Okay? And we will be left with some amount of grams. How many? Okay, there better be at least be 3 sig figs there. 15.0 grams of NaOH. Questions? Okay, you can do the next 5 problems, ladies and gentlemen. No, calcium's not in it. Nah. If you have questions, if you need help, ladies and gentlemen, raise your hand. I will be happy to come around and give you some assistance.
Phosphate, yeah.